Hello classmates, today we will learn about the reheating heater and its system. We will learn about the structure of the reheating heater, working principle, and regenerative system. Regenerative heater utilize the extraction steam from the steam turbine, heating boiler, feed water, heat exchange equipment to improve cycle efficiency. It has different types, classified by heat transfer method. Regenerative heater. It can be divided into hybrid heater and surface heater. The steam of the hybrid heater comes into direct contact with the feed water. No heat transfer and difference. Surface heaters transfer heat through metal walls. In the feed water reheating system, only the derivative serves as a hybrid heater. The rest of the heaters are surface heaters, divided according to the arrangement method. Regenerative heaters can be divided into horizontal and vertical types. The heat transfer effect of the horizontal heater is good. Large capacity units widely use horizontal heaters. Third, according to the pressure on the water side, it can be divided into high pressure heaters and low pressure heaters. This is the position of the heater in the system. The water first goes through a low pressure system, moving on to the deaerator, then to gaojia. Let's take a look at the commonly used surfaces, which are heaters. Its hydrophobic behavior. What is the aim of a heater? The extracted steam condenses into water in the heater. It's called hydrophobicity. There are two ways to drain water. One is the hydrophobic stepwise self-flowing method. It utilizes the pressure difference between the heaters. Let the hydrophobic gradually flow into the lower pressure steam space of adjacent heaters. This method uses a higher level heater. Its hydrophobicity will squeeze out the extraction steam of the lower pressure heater. Its thermal economy is poor, but simple and reliable. Another hydrophobic method is to use a hydrophobic pump. In this way, it's done through a drain pump, drain the water from the heater. The main condensate pipeline sent to the outlet of the heater at this level, just like this way in the picture. Its investment is high, common electricity consumption will also be high, maintenance costs will increase. We often adopt a hydrophobic to promote self-flowing method. Next, let's take a look at the structural principle of the heater. This is the structure of a high-pressure heater. Let's take a look at the structure of high pressure together. This is the casing of the high-pressure. There are water supply inlets and outlets on top. Import of steam. Normal drainage, accident drainage, superior drainage, inlet short pipe. The main components of the high-pressure reactor include composite water heat exchange tubes, supporting plate, cladding tube, anti-collision board. The water potential is a hemispherical one force. The interior of the water chamber is equipped with a partition formed by two elements. The water chamber manhole adopts a high-pressure manhole self-sealing structure. The piping system consists of two plates. Composed of U-shaped pipe partitions and other components, the workflow of high pressure is as follows. The high pressure heater is a shell and tube heat exchanger. When high pressure working, the water supply process is a U-shaped pipe with a water inlet. Upper water supply outlet. Three heat transfer sections are set on the steam side. Overheated steam cooling section, condensation section, hydrophobic cooling section, high-pressure superheated steam extracted from the steam turbine. Firstly, enter the high-pressure superheated steam cooling section. Below the steam inlet connection, there is a stainless steel anti-collision plate. Avoid direct steam flushing of the tube bundle. The steam is separated by several partitions along the edge. S-shaped pipeline flow composed of staggered spacing arrangement, convective heat transfer with the feed water inside the U-shaped tube to water heated to a temperature higher than or equal to the saturation temperature of steam. Saturated steam with a certain degree of superheat. Enter the saturated steam condensation section, heat exchange with water supply, steam condensation section. It is the heat released before. Vaporization during steam condensation, heating water supply. It is the main heat transfer area of the high-pressure reactor. Steam flows rapidly into the entire condensation section along the entire piping system. Heating steam in the tube bundle releases a large amount of pre-vaporization heat, and it condenses into a saturated hydrophobic non-condensable vapor exhaust from the exhaust pipe at the center of the bundle. At the tail of the high-pressure river body, superior drainage enters the oil room, an independent expansion chamber separated by punching plates. After expansion, drain the water from the local heater, enter the hydrophobic cooling section together. The hydrophobic cooling section will be drained from the condensation section. Continue cooling release heat to heat the water supply. Reduce the temperature of condensed water to below the saturation temperature. Improve the thermal efficiency of the unit. The cooling section adopts a submersible entrance. The mouth end of the west entrance is located below the condensate water level, make it impossible for steam to pass through. Condensed water is guided by a cooling baffle. Flow along the axial direction, flow out of the high-pressure heater. At this level through the drain outlet, automatically flow to the next level of high-pressure heater through the sharp pressure fork. At D, the external interface of Guanchen has water supply inlet and outlet. Enter Guangchen water outlet, pipeline safety, valve interface, pipeline exhaust port. Start the exhaust port of the pipeline, low addition synthesis. The external interface has a steam inlet. Drainage outlet, micro-emergency drainage outlet, safety valve interface, start-stop exhaust port, operating exhaust outlet and synthetic water outlet, local water level sending interface, superior drain inlet water level transmitter interface, etc. Job-wise addition consists of a condensation section and a hydrophobic cooling section. The main components of job-wise addition include the combined water potential tube system, support board, protective plates for cladding tube. The water chamber is in the form of a hemispherical wind head and equipped with maintenance manholes. The interior of the water chamber is equipped a partition formed by two elements, thin oil tube plate composed of U-shaped pipe support plate, etc. The hydrophobic cooling section is a tightly sealed steel structure. The enclosure is arranged with several partitions staggered and spaced apart, make hydrophobic flow more conductive to heat transfer. Next, let's take a look at the regenerative extraction system. This is a diagram of the regenerative extraction steam system. For a 600 megawatt unit, it has a total of 8 non-adjustable extraction stages. The first extraction steam is led to the high-pressure cylinder, total 1 high voltage. The second stage of steam extraction is led to the high-pressure cylinder. Exhaust steam, supply backup steam source for number 2 high-pressure heater and auxiliary steam. The third stage of steam extraction is led from the intermediate pressure cylinder, supply number 3 high-pressure heater. The fourth stage of steam extraction is led from the intermediate pressure cylinder, exhaust, gas supply, oxygen device, feed water pump, turbine, and auxiliary steam system. The extraction steam from section 5 to 8 is led to the low-pressure cylinder, supply 5 to 8 low-pressure heaters separately, except for the extraction of steam. In the 7th and 8th sections on the extraction steam pipeline, both pneumatic check valves and electric shut-off valves are installed. Passing through the 8th one by one after the condensate is pressurized by the feed pump, this is the drainage system of the heater. 7, 6, and 5 low-pressure heaters and deaerators. After deoxygenation, it is pressurized by the feed water pump. After passing through number 3, number 2, and number 1 high-pressure reactors, it enters the boiler. We can see here all hydrophobic systems adopt a step-by-step, self-flowing method. During normal operation, the drainage of the number 1 high-pressure reactor flows into the number 2 high-pressure reactor step-by-step. Step-by-step flow from the second high-pressure reactor to the third high-pressure reactor. Oxygen generator at inlet of number 3 high-pressure reactor, and the low-pressure condensate flow step-by-step to the condenser. The excitant drainage will flow directly to the condenser. hydrophobic expansion vessel. The above is the extraction system of the reheating heater and hydrophobic system. Students, in this class, we introduced the structure of reheating heater, working principle and system. I hope everyone will review more after class. Timely grasp. Thank you, everyone.